Yesterday we discussed about the router. We discussed about router interfaces, how many internal components are there into the router. There are different kind of memories like RAM, ROM, NVRAM and flash memory. Then we discussed about how to configure a device, like how to configure console port security, auxiliary port security, telnet, SSH, HTTP, and how to assign IP address to the interface. After that, we discussed about routing. We configured static routing and default routing. And after that, we discussed about discovery protocol, which is CDP and LLDP. Before going to start the next topic, let me know if you have any doubt in day one topics. So we can discuss right now. Any doubt, any issue in day one topics?
Good morning, everyone. It's Verity. Sorry for the delay.
Okay, not an issue. Okay. So yesterday we discussed about static and default routing. Today we are going to discuss dynamic routing, IPv4 dynamic routing. And after that, we'll discuss about the security features, security, access control list, and NAT, network address translation. Dynamic routing. In static route and default route, you have to give destination network information. Who is your destination, or if you want to communicate to all the destination, what is your default gateway? But in the dynamic routing, there is no requirement to give the destination information. You have to just give your own network information. Okay. So dynamic routing is done with the help of dynamic routing protocol.
Sorry to interject, but are you sharing your screen? Because I'm not seeing anything on my end.
Wait.
Thank you.
Dynamic routing is done with the help of dynamic routing protocol. Dynamic routing protocol categorized into two categories. One is IGP, Interior Gateway Protocol. EGP, Exterior Gateway Protocol. IGP protocol work within same AS. AS is autonomous system. Or within site. Whereas EGP work between AS number. How? Let's say you have one branch here. Let's say this is my site A and here is my site B. So inside the site A, you can run any IGP protocol. For example, RIP, EIGRP, any protocol you can run. Here also you can run RIP, EIGRP within the site. If you want to connect these two branches, in that case you have to run EGP protocol, which is BGP version 4. Any confusion?
Nope, clear here.
Further, this IGP protocol categorized into three main categories. One is distance vector, link state, and hybrid. Distance vector protocol select best path by judging the or you can say select the best path based on number of hop count. Based on number of hop count. Lesser the number of hop count, route will be more reliable. Here we have example RIP, routing information protocol. We'll discuss this thing right now. Then we have link state protocol. Select best path with the help of bandwidth. Higher bandwidth, lower will be cost, and lower cost route will be more preferred. Here we have example of OSPF, open shortest path first. and ISIS, intermediate system to intermediate system. Then hybrid have both the characteristics of distance vector as well as link state. Here we have an example, EIGRP, Enhanced Interior Gateway Routing Protocol. So we have to discuss about RIP, OSPF and EIGRP. Now, autonomous system number, AS number. Now, what is autonomous system number? It's logical grouping of IP subnets under a single administrative control. EIGRP and BGP use AS number. So it's like that. If you are configuring your network and in your network there are 10 IP subnets, so you can define in EIGRP and BGP, you can define a AS number. It's a numerical number, for example, like 10, 20, 30, 40, and you can define all your IP subnets are coming under that particular AS number. After that, we have administrative distance, AD value. AD value provide trustworthiness of a route. Means how much a route is reliable. Lower AD value route will be more reliable. AD value range 0 to 255. Every protocol having a predefined AD value. For example, if you have static or default, then AD value will be 1. Default AD. If you have RIP protocol, then 120. If you have OSPF, 110. If you have EIGRP, 90 and 170. These are the predefined values. If you want to change, you can change it. These are default. No. How this AD value works? Let's say we have this network. Here is my destination. Here is my source. Let's say in first path, this upper path, I configure here RIP. In middle path, I configure static. And in the lower path, here, I configure OSPF. So on this router, RIP, static route, and OSPF, all three protocols are working. So when this source is sending any traffic to the destination, so firstly traffic will reach to the R1 router. Now R1 router will check the routing table. So in that routing table, it will get static routing is configured, RIP is configured, OSPF is configured. So which route will be the best route? So in that type of scenario, AD value check out. So it will check OSPF is having 110, static having 1 and 120. Lower the ID value, route will be more reliable. So R1 will send traffic to R3 and R3 to R7 and then destination. In any situation, let's say this route goes down. So again, there will be a re-election. It will check on which path it is having the lower AD value. So it will get OSPF is having lower AD value. So next path will be via R4. Clear this thing?
Yes.
No. Best route selection by the router. So first, it will check highest prefix length. Highest prefix length means, let's say we have two paths. This is my source, this is my destination. So on this path, I have /28, here I have /26. So it will prefer this path, highest prefix length. if prefix is same, then lower AD value. If AD value is same, lower metric value. If metric is same, then load balance. Now let's say on both the path I configure, let's say RIP. So RIP is working on number of hop count. So it will check how many routers are there between source to destination. So lesser the number of hop count, route will be more reliable. So let's assume both path we have 26, 26. So prefix length tie. Then next it will check AD value on both the path. RIP is configured, so AD value is 120. Again there is a tie. Then it will check lower metric value. Metric value is again it will be same 1 2 3 1 2 3. After crossing 3 hops it is reaching to the destination. So metric is also same. So if metric is also same, then half of the data will transfer through upper link and half of the data will transfer to the lower link. This is called load balancing, equal cost load balancing. And by default every protocol will support 4 equal path. RIP. RIP is routing information protocol. RIP is pure distance vector protocol. Select best path based on number of hop count. Hop count are basically routers between source to destination. RIP support maximum hop 15. Means if my destination is more than 15th hop, then you cannot communicate with the help of RIP. AD 120. Work on UDP port number 520. RIP is having 2 version. RIP version 1, RIP version 2. What is the difference between version 1 and version 2?
I honestly don't know.
Any question? RIP version 1. Support class full network. And RIP version 2 support class less network. Any idea about class full and class less network? Anyone?
It doesn't use the default size of the network for like class A and class B, class C. So you can use variable length subnets.
Yes. So for example, if I'm writing a IP address 10.0.0.10, it belongs to which class? Class A, right?
Yes.
If I'm writing the same class A subnet mask, this is known as class full network. Same IP, but if you use like this way, subnet mask is not default subnet mask of that particular class. So that IP is known as class less network. So what is class full network? If an IP have a default subnet mask with respect to the default class, that IP is known as class full network. If an IP doesn't have the default subnet mask with respect to the class, that IP is known as classless network. Okay. Next. RIP version 1 doesn't support authentication. RIP version 2 support authentication. RIP version 1 SAN routing update on broadcast address 255.255.255.255. RIP version 2 SAN routing update on multicast address 224.0.0.9. Doesn't support discontinuous network and its support. Continuous network. So these are some differences. How we have to configure this thing, we'll see that thing next. Next. RIP timers. in RIP we have 4 timers. Update, (30-second), invalid, 180-second, hold down, 180-second, flush, 240-second. These are the 4 timers into RIP. So understand how the dynamic routing works and how these timers works. Let's say in this network, I configure RIP. I configure RIP on R1 and on R2. So when you are configuring RIP or any dynamic routing protocol, you have to advertise your own information. So for example, R1 is having network 10 and 12. R2 is having network 12 and 20. So firstly, when you configure RIP on R1 and R2, they will exchange update packet to each other. In this update packet, they will exchange this information, what is directly connected on that particular router. So let's assume first R2 is sending that update packet to R1. So R1 will receive this update packet and it will check, okay, network 12 I have, network 10 is directly connected with me. For me, 20 is the new network. So whatever is the new network, it will add into the routing table. Same way, R1 will send update packet to R2 and R2 will put network 10 information. So in this way, they are exchanging the routing packet and they are identifying all the destination. So in the dynamic routing, destinations are find out automatically. There is no need to tell who is your destination. So destination information identify automatically. These update packets travel in every 30 seconds periodically. Now let us assume R1 and R2 routing table is working fine. After some time, let's say on R1 this network goes down, network 10 goes down. So in the next update, R1 is not sending this 10 information, but in R2 network 10 information is there. So how much time I will wait? I will wait maximum 180 seconds. So if I receive this information within 180 seconds, then my routing table will be stable. If I'm not receiving this route, network 10 route within 180 seconds, I will say this route is invalid. The route is invalid, but it can stay in my routing table. So once a route is invalid, hold down timer starts. Once it reaches to 240 seconds, it will automatically flush this network 10 entry from the R2. But let's say this information I am receiving within 240 seconds. So it will remove this invalid entry and it will be the correct entry in my routing table. Any question in this timers? So RIP is having 4 timer, update timer, invalid timer, hold down timer and flush timer. If you want to change these default timers, you can change it. No. Let's do the lab. So this is the same yesterday topology. In this topology, yesterday we configure static routing and default routing. So firstly check show run. So IP addressing is there. Okay. Default route is there. So I remove this default route on R1. On R2 we have two static routes. Here we have a default route. So now we have to configure RIP. So to configure RIP, first command will be router RIP. Enter. And in the router RIP, you have to define what networks are directly connected with you. Means on R1. So network is the command, and then you have to define network 10.0.0. This network is directly connected with me. Then network 12. So I'm just giving the directly connected network information. Okay. If you want to define the version, there is a command version, and you can define which version you want to define, version 1 or version 2. So right now I'm leaving this version default. On R2, we have three network, 12, 23 and 20. On R3, We have 23 and 30. So this is the configuration of the RIP. So let's verify this thing. If you are on R1, first command will be show IP route. In show IP route, you can see there are some routes which is learned via R, capital R. Capital R means RIP. So it automatically discover all the destination. If I run here, show IP protocols. So you can see now, previously when we run show IP protocol, then there is a no information, but right now it is showing the routing protocol is RIP. It is sending routing update in 30 seconds. Invalid is 180, hold down is 180, flush after 240 seconds. Maximum path 4 means it support maximum equal 4 path. 4 equal path load balancing. These networks you advertise. Distance, this is administrative distance is 120. By default, if you are not specifying any version, then the default nature is it can send version 1 packet, it can receive version 1 packet, but it cannot send version 2 packets. This is the default behavior. It can send version 1 packet, it can receive version 1 and version 2 both. But in the default behavior, router RIP cannot send version 2 packet. If you want to send version 2 packet specifically into the router RIP mode, you have to enable version and version 2. Clear this thing? Now if you want to communicate, let's say 30.3, you are able to communicate. So this is the RIP. Right now we have only one connectivity here. Okay. you are on PC 0. If I ping 33, I'm able to ping okay. In tracer, it is showing firstly my traffic is going to the R1 router. R1 is sending that traffic to the R2. R2 is sending R3 and R3 is sending to the destination. Right now we have only one path, right? So that's why my traffic is moving through that path. So let's say if we have multiple paths, so I'm just enabling this alternate path. I will assign 13 network IP address and I will advertise this 13 network to R1 and R3. So RIP is the slow protocol, so it takes some time to synchronize the table once again. You can see the output now. Previously, when the 13 network is not into the picture, then it is sending the traffic to R1, R2, R3, then destination. Now, see, firstly it is sending traffic to R1. R1 is directly sending that traffic to R3 and R3 to destination. Why? Because RIP is working on hop count, number of hop count. Lesser the number of hop count, route will be more reliable. So if I'm going from upper path via 13, so hop count 2. Why 2? 1, 2, then destination. But if I'm going via lower path, so number of hop count is 1, 2, 3, then destination. So here number of hop is 3. So lesser the number of hop, route will be more reliable. Clear this thing? Any confusion in the RIP working?
I'm good.
In ShoIP protocols, you can see it can send version 1, it can receive version 1 and version 2. But let's say if I change the version on one router, what will happen? Router RIP. On the first router, I'm defining version 2. So if you define version 2, a specific version, in that case, that router will receive and send both version 2 packet. So let's see what will happen now. If I run here show IP protocols, so you can see now it is support sending and receiving both version 2. Show IP route. See these timers. I'm just waiting for 180 second. Let's see what will happen after 180 second. 180 second means 3 minutes. You can see this possibly down. That possibly down is representing now the route is invalid. Why the route is invalid? Because you configure here version 2. And in the default behavior of the router RIP, R2 and R3, they are sending version 1 packet. So this router is not receiving those routes because it requires now version 2. So that's why those old entries in my routing table become invalid. So after 240 seconds, those entry will be automatically flush. So you can see all the net routes which is learned by RIP is possibly down. But let's say if I change the version on version 2, so everywhere is now version 2. Previously it is showing possibly down. You can see now the table is refreshed automatically. Once it receives version 2, it will automatically synchronize the table once again. And now all the entries are here perfect. So if you want to ping anywhere, you can ping. Clear all those timers and RIP configuration, version 1, version 2.
Yep.
So if you want to remove RIP configuration, in that case, you have to just remove the routing protocol. No router RIP. The whole configuration of the RIP will remove. No router RIP. It is not showing any output. That means the RIP protocol is removed. Okay. Next protocol is EIGRP. EIGRP is enhance interior gateway routing protocol. Enhance interior gateway routing protocol. Directly access this. Okay. In RIP, there are some commands. Let's discuss those commands first, then we'll discuss the EIGRP. So version command we already discussed. Okay. If you want to change the timer, this is the command. So you have to go to the router RIP and you have to define timer space basic. Then first is your update timer, invalid timer, hold down timer, and flush timer. So you have to give the complete information, means all 4 timers. Okay. Like we have physical interfaces present on the router or on the switch. Same way you can create the logical interfaces. Those logical interfaces are known as loopback interfaces. So if you want to create loopback interface, you can simply create interface loopback 0. Any number you can take till 65,535. So interface loopback 0, and you can define any IP address there. There is a command no auto summary. Right now this no auto summary command is automatically enabled into the routers. Now what this auto summary is doing, for example, let's say you are using the subnetted network into the network, like VLSM and subnetting you are doing in your network, and you are using the same IP subnet in the routing. In that case, if you are using the subnetted network and you are doing routing, automatically your router is doing route summarization. We'll discuss the route summarization into the EIGRP. Now route summarization, it will summarize all the multiple route into a single summary route, and that will be into your routing table. So if you don't want that particular summary route, in that case you have to enter this no auto summary command. For example, somewhere they advertise this network 192.168.1.0. Now in the routing table there are two entries, 192.168.1.0/24 and 192.168.1.4/30. That 4/30, this is the actual entry which network is present in my network. This first entry is coming automatically via route summarization, auto summarization. Then we have a passive interface. RIP protocol is working globally. So when you are running this command router RIP and you are defining the network, so particular that network automatically send and receive the RIP update. So on this R1 we have these interfaces, three interfaces. You configure here router RIP on this router. So RIP will start sending on all the interfaces. You know, on this interface I am receiving the same information, whatever information I am receiving from these two interfaces, and I am sending the same information from this way, and this way. There is a thing passive interface. Stop sending update. Now, if you don't want to send the routing update on this direction, so what you can define that interface as a passive interface. So it will not send routing update into in this direction, but it can receive the update. So this is the passive interface. You can define like this. Go to the router RIP, passive interface, and whatever is the interface number. If you are putting passive interface default, it will put all the interfaces as a passive interface. default information originate. Okay. Let's say we have this ISP. This is my internal network, which is configured with the RIP. This ISP is connecting to the internet. So as we discussed yesterday, when we connect with the ISP, can I run here RIP protocol? First thing, here RIP is running in my inside network. Can I configure RIP with the service provider? Yes, anyone?
No.
Okay. Anyone who is telling we can configure and there will be no issue? No, we cannot configure. Why? Because if we configure RIP here, then the internal information will reach to the service provider, which is not good. In that case, there will be no security. So, instead of routing protocol, we are using default route there. So here I put a default route to connect with the service provider. But this is the default route and here we have RIP. These are two different protocols. So this default route will not come automatically to the RIP network. So to advertise this default route into the RIP network, you have to run this command. Default information originate. So once you run this command on R1, R1 will automatically advertise this default route information to R2 and R3. So default information originate is the command to advertise the default information to the RIP network. So we have this topology, we will do this lab. There is a command show IP RIP database. It will give you the RIP database information like this way. Okay, IPv6 will do at the end of the course. Actually, this PPT is not in a systematic way. So firstly they will start routing static route and default route, then they are doing ACL and NAT, then again they are doing RIP. So what I'm going to do now, we are firstly finish the routing part, all the protocols, RIP, EIGRP, OSPF, then we'll do the security in a systematic way. But ultimately, we are doing all the topics, whatever topics are there in your curriculum. So you can see EIGRP is at the end of the course. Okay. So let's start EIGRP. EIGRP, Enhanced Interior Gateway Routing Protocol. So as we already discussed, EIGRP is having both the characteristics of the distance vector as well as link state protocol. Previously, in distance vector, we had two protocols. One is RIP and one is EIGRP. We can see RIP is a slow protocol. How? Because it is removing the wrong information in 240 seconds. And in the production environment, 240 seconds is a big time. This EIGRP is more slower than RIP. And it support only class full network. So there are lots of limitation in this EIGRP protocol. So Cisco add some link state property in EIGRP. And they discover a new protocol which is EIGRP. So now what are the property in EIGRP? First, it is a advanced distance vector protocol. It is Cisco proprietary right now. Means this EIGRP is working only on the Cisco routers. It support classless network. It support VLSM and CIDR. CIDR is classless interdomain routing. We'll discuss that part. Now maximum hops 255, whereas in RIP we have 15. Use AS number, autonomous system number. It send routing update on multicast address. These multicast address are fixed for the particular protocol. For example, RIP we have RIP version 2, 224.0.0.9. So remember these multicast addresses. There will be a question in your exam based on these multicast addresses. EIGRP use dual algorithm. Dual is diffusing update algorithm. EIGRP use hello packet to form neighborship. EIGRP hello on point to point link. Point to point, like two routers are directly connected. Second. EIGRP hello on WAN. WAN means two routers are connected with the help of service provider. Hold down timer on P2P link. 15 seconds. Hold down timer on WAN 180 seconds. So hello and hold down relationship is, hold down is 3 times of your hello. EIGRP metric depend on bandwidth, load, reliability, delay, and MTU. EIGRP K values, or you can say EIGRP weight. So in EIGRP we have 5 values: K1, K2, K3, K4, K5. K1 is 1, K2 0, K3 1, 0. These K values are used to calculate the best route basically. EIGRP tables. In EIGRP we have 3 tables. One is neighbor table. Second one, topology table. And third one is routing table. So let us assume we have these two routers, R1 and R2. These are the networks like this way. So firstly, when you configure EIGRP, both the routers will send hello packet first. That hello packet is used to form the neighborship. In this hello packet, there are certain parameters which must be matched to form the neighborship. So if all the parameters are matched, then neighborship will form and the neighbor information will come to the neighbor table. Next, once neighborship is done, they will exchange the update packet. So in that update packet, there is a information how many networks I have. So that entry will go to the topology table. In topology table, you will get all possible route. And in the routing table, you will get only the best route. Any question?
Nope.
No. Successor. Successor is best route. Feasible successor, alternate best route after successor. But to become a route as feasible successor, that route must meet feasible successor condition. Now, what is this feasible successor condition? AD of here AD means advertised distance. AD of feasible successor must be less than FD, feasible distance. AD of feasible successor must be less than FD of current successor route. If a route is meeting to this condition, then a route can be a feasible successor. Now, let's assume this upper path is my successor, best path. Now, so here we had two new terms, AD and FD. AD is cost from next hop to destination. That means if this is my successor, so cost from here to here, this is known as AD. And FD is the total cost. Total cost source to destination. Means the cost from here to here. Clear this thing? Any question?
Nope.
Okay. Now let's discuss this successor and feasible successor. Let's say if we have this network. And here is my destination. Oops. 10, 5. This 10 and 5, these are the cost values, metric values, basically on that particular link. So let's say A, B, C, D, E. So I'm on C. I want to reach this destination, which is on router A. So I have two paths. Either I can go via this route or I can go via D. So when a router is having multiple paths in the EIGRP, firstly it will check the FD value. So in this case, if I'm going via B, then FD and AD. If I'm going via B, then FD is total cost. So 10 plus 5, 15. If I'm calculating AD, AD is the cost from next hop to the destination. So 5. If I'm going via D, then FD and AD. 10, 10, 10, 5 means 35 and 25. So firstly, on both the way, router will check on which path a router is getting lower FD value. So lower FD value is on B, 15, 35, right? So that route will become successor. So now we have to check this route can be a feasible successor or not. So for that we have a condition. AD of feasible successor must be less than of FD of feasible successor, which is not true in this case. So there will be no feasible successor because the condition is not matching. 25 is greater than 15. Clear? Let's say if I change this scenario, no. If I have this scenario, so in that case, if I'm going via B, FD, AD, FD will be same, 15, AD will be 5, and via D, FD, AD, FD will be total 10, 19, and 9. So if you see, in that case, AD of, okay, firstly, it will check FD, so that will become successor again, because 15 is less than 19. Then for the feasible successor, it will check AD of feasible successor must be less than FD of the current successor route. So in that case, this condition is satisfied, so that route can be a feasible successor. Clear that thing? And feasible successor stay in topology table. Feasible successor stay only in topology table. That will not go to the routing table. EIGRP packets. In EIGRP, we have 5 packets. Hello, update, query packet, reply, and acknowledgement. Hello packet is used to form the neighborship. Update packet is used to exchange the routing update. Query packet will travel only in one situation if your best route goes down. Reply is the response of the query, and acknowledgement is acknowledgement. I receive the update. Neighborship condition. Okay. This point is very important in terms of troubleshooting the network. Let's say EIGRP network. There is some problem. So first task, you have to see the neighborship table. If the neighborship is not there, then there will be no routing update. So first verification you have to do with the neighborship. So there are some conditions to form the neighborship in case of EIGRP. First, same AS number, same authentication, type and password, same subnet, same EIGRP key values, same hello and hold down timer. These parameters must be matched on both the routers. If they match, then the neighborship will form. And if there is no neighborship, in that case, you have to see only these 5 parameters. So in EIGRP features, we discuss about the rapid convergence. The convergence will be fast. Okay. Rapid convergence. EIGRP send partial update. Like RIP, whenever RIP is sending update, it will send the complete routing table every time in every 30 seconds. Whereas EIGRP will send partial update. Partial update means whatever information is updated information is there, only that information will be propagate to the neighboring device. And EIGRP send triggered update. Triggered update means whenever there is a change, it will send immediately. It will not wait for the 30 second or 180 second. Load balancing, by default it support 4 equal path coast load balancing. It's a loop free protocol. It support classless routing, reduced bandwidth, EIGRP path selection. This thing we already discussed, like how the AD and FD will work. EIGRP metric. EIGRP metric depend on bandwidth and delay by default. So this is the formula. Metric will be bandwidth plus delay into 256. So this is the formula to calculate the metric value of EIGRP. No need to do manual calculation. Your router is doing the complete calculation automatically. So this is the topology. We have the same kind of topology. Okay. How to configure EIGRP? So to configure the EIGRP, you have to write router EIGRP and 100. 100 is the AS number. That AS number must be same on all the routers within the site. So when you configure this branch router 100, you have to configure this HQ router also 100. Otherwise, you are not able to communicate. So router EIGRP, you have to define the same directly connected network, directly connected network. Show IP EIGRP neighbors. This command will display the neighbor information. Like they are running this command on HQ router and they have one neighbor 192.168.1.1. There is a command show IP EIGRP interfaces. This command will display on which interface you enable the EIGRP. If you write show IP route, so there will be some route which is coming with capital D. So capital D represent EIGRP routes. And if you see this output, you will get the destination network, and after that you are getting this 90. 90 means your AD value, and after that you are getting this FD value. Show IP EIGRP topology. This command will give the information, okay, of your topology table. All possible routes will stay in your topology table. Same passive interface is there. So passive interface is used to prevent sending the routing update on that particular interface. So you can define this thing. So these are the K values which we already discussed. Load balancing will be for equal path. So we have this network. So now in this network, I'm going to do EIGRP. So for EIGRP, router EIGRP, and you can take any AS number, but that AS number must be same on all the routers. So you can take till 65,535. So here I'm taking 100, let's say. After that, you have to define the network and the directly connected network. So on R1, there is network 10, network 12, and network 13. Exit. Same way on R2, router EIGRP 100, network 12. So you can see once I enter this network 12, so it make the neighborship with R1, because once I configure router EIGRP, enabling the EIGRP protocol is sending the hello packet to the R1. So based on the hello packet, it form the neighborship. So R3 make two neighborship, one with the R2 and one with the R1. So let's verify each and everything now. So configuration is done. So first command is show IP EIGRP neighbors. So R1 is connected with R3 and R2. So it should give two neighbor information. You can see now. There are two neighbors. Under this process 100. Show IP EIGRP interfaces. So this command will give the information on which interface EIGRP protocol is running. Then show IP EIGRP topology. Show IP EIGRP topology. This topology table will give the information of all possible route information. So you can see okay. So you can see here 23 is having equal cost load balancing. It is receiving via 12.2 as well as on 13.2. Show IP route. So in the show IP route, the routes which is coming from capital D, those routes are EIGRP routes. And they are coming with AD value 90. And this is the FD value. This is the gateway information. Okay, there are two type of load balancing. EIGRP support unequal cost load balancing. This unequal cost load balancing feature supported by only EIGRP. Now, what is the meaning of this equal and unequal cost load balancing? You can see there are two routers, R1 and router A and router B, which is connected via two ways, upper way and lower way. Both the way we are getting metric value is 100. So when A will send any data to B, the traffic will go via upper way and the lower path, both. This is called as equal cost load balancing. But unequal cost load balancing, let's say in upper way, upper path we have metric value 90 and in the lower path we have metric value 25. So by default it take lower metric value. So it will prefer only this lower path. But there is some configuration if you want to include this path also for the load balancing. Means you want to distribute the load of this particular link, then you can send some amount of data on this upper path also. So that type of configuration is known as unequal cost load balancing. Any question till now in EIGRP?
None here.
Yes, anyone is having any question regarding the theory part, regarding the configuration part?
I'm good here.
So let's take a break of 10 minutes and then we'll connect once again.
Sounds good.
Everyone is here?
I'm back.
I'm here.
Okay. So there is a discovery lab 26. Start this lab and perform this RIP version 2. And if you are getting any issue, then let me know. So firstly, we'll finish RIP version 2 lab. Then EIGRP lab. Then we'll move to OSPF. We'll finish OSPF and then we'll move to the security. Clear?
Yes.
Everyone will start discovery number 26. And let me know if you are getting any issue.
Very well.
Now, OSPF. Open shortest path first. OSPF is link state protocol. Now link state protocol have three basic characteristics. First, they send partial update. They send trigger update. And they send a topology refreshment in every 30 minutes. OSPF is open standard protocol. Means this protocol will work on all the vendors. OSPF support classless network, support VLSM and CIDR classless interdomain routing. OSPF use area ID. Like EIGRP is using ACE number, OSPF is using area ID. AD value 110. OSPF send routing update on multicast address 224.0.0.5 and 224.0.0.6. OSPF use SPF algorithm, shortest path first. OSPF use wildcard masking, inverse masking. So now what is wildcard mask? Let's say your subnet mask is 255.0.0.0, and if you want to calculate the wildcard mask of this, this is your full octet. From the full octet, you have to subtract your subnet mask. So whatever value will come, this is your wildcard mask. Clear this thing? OSPF metric 10 to raise power 8 upon the bandwidth. This is the formula to calculate the OSPF cost or metric. OSPF use hello packet to form neighborship. OSPF hello on point-to-point link 10 second. Hello on WAN 30 second. Dead interval 40 second. So dead interval is 4 time of your hello. So let's say these are the two routers. They will send hello packet in every 10 second. Let's say one router is not sending me a hello. So I will wait maximum 40 second. Within 40 second, if the message came, then the neighborship will form. Otherwise, I will discard the neighborship.
Excuse me, does it then send another hello, another 10 seconds after it's been discarded?
Yes, hello packets are periodic, just to make sure the neighborship is there or not. So in every 10 second, if the link is point to point, means the routers are connected directly. In that case, hello packet travel in 10 second. If the two routers are connected with the help of ISP, service provider, and there are some technology, for example, like frame relay is there, MPLS is there. In that case, the hello packet will travel in 30 seconds.
Okay. Thank you.
Okay. Like EIGRP, we have 3 tables. Same way we have here neighbor table. Here neighbor table is known as adjacency database. Then topology table, and routing table. If you want to verify all these things, so you can run show IP OSPF neighbors. Show IP OSPF database. And show IP route. OSPF terminology. Okay. In OSPF terminology, first thing is backbone area. Area 0. In case of OSPF, area 0 is backbone area, and all OSPF area must be directly or indirectly connected with area 0. Otherwise, the route information will not propagate. Then we have ABR, area border router, the router which connect two or more OSPF areas. So here R2, R3 and R6, these are my ABR. So this is ABR, ABR, ABR. So ABR is that router which is connecting two or more OSPF areas. Then ASBR, autonomous system border router, R4 and R7. The router which connect two different routing protocol. For example, here R4 is connecting EIGRP and OSPF. R7 is connecting OSPF and DRIP. No need to define ABR or ASBR. That router will automatically detect. Virtual link. Now, if you see this area 3, area 3 is not directly connected with area 0. So the area which is not directly connected with area 0, that route information will not travel to anywhere. But this area is the part of my network. So if you want to connect, so here you have to create a virtual link. So virtual link provide a indirect connectivity to that area which is not directly connected with area 0. And virtual link you have to create ABR to ABR. Any question?
I have a question because can you just repeat what the very first part about what the virtual link is? Because you said it's not directly connected to area 0, but from where you drew the line, it looks to me like it was. So I'm a little bit confused.
See, in case of OSPF, there is a condition. In OSPF, all areas must be directly or indirectly connected with area 0. So if you see area number 1 and area number 2, these are directly connected via this R2 and R3, right? But this area 3 is not directly connected with area 0. So whatever routes are there, those routes will not travel to area 0. So if they are not traveling to area 0, then they will not travel to area 1 and they will not travel to area, in EIGRP. Just to advertise all the routes or to travel all the routes into the OSPF domain, you have to create the virtual link. This virtual link provide a indirect connectivity to area 3, and once you make the virtual link, so logically area 1 boundary will be like this way. So virtual link is basically extending the area 1 boundary. So once the virtual link will create, R3 will assume I am directly connecting with area 0. Clear now?
Yeah. Yes. Thank you very much.
link state advertisement. In case of OSPF, every update is known as LSA, link state advertisement. No. Area. Backbone area, which is area 0. Apart from area 0, all areas known as regular or standard area. When you configure OSPF, you can configure as a single area and you can configure as a multi area. Now single area means I configure all these routers under area 0, single area configuration. Area 1. So multiple area means some routers are in area 0, some routers are in area 1, this way. OSPF packet. Like EIGRP, we have same 5 type of packets here. Hello, DBD, database description, LSR, LSU, LSEC. LSR is link state request, LSU, link state update, LSEC, link state acknowledgement. Let's say we have these 2 routers. So firstly, when you configure OSPF, they will send hello to each other. Once the hello match, then neighborship will form. Once the neighborship will form, they will send update packet. Both the router will send update packet. That update packet is known DBD packet here. So in that DBD packet, the complete routing table information will be there. Once they exchange the database description packet, they will make the routing table. Let's say R2 is sending, on R2 there are lots of networks. So R2 is sending a DBD packet to R1. R1 receive that information and put all the information into the routing table. But let's say there is a network 40.0.0.0. For that 40.0.0, I'm not getting the complete information on R1. So what R1 will do, R1 will send a LSR for 40 network. And in that LSR, there is a information, please provide me the full information regarding the 40 network. So when the LSR received by R2 will send LSU, link state update, to R1, and in that LSU packet it will give you the complete information regarding the 40. Once LSU packet is received by R1, R1 will send LS ACK, link state acknowledgement, to R2, which is giving that information. I received the LSU. Okay, this is the OSPF packet information. OSPF in multi-access network. OSPF in multi-access network means let's say I configure all these routers under the area 0. Okay. Once you configure OSPF on all the routers, then every router will make the neighborship, right? Now tell me, if you configure OSPF on all the router, on R1, how many neighbors you will get?
Four.
Yes, 4. Every router will make 4 neighbors because the switch is behaving as a transparent device. So whenever there is a update on R1, R1 will send that update to all the neighbors. Once this update received by R2, R2 will send this update to all the neighbors. So this process will be done by each and every neighbor, and every router will start sending the same information to each other. So there will be a unnecessary network traffic generated in your network. To resolve this problem, there is a DR-BDR concept. DR is designated router, BDR is backup designated router. So in multi-access network means where the routers are connected through a switch or connected through the fast Ethernet cable. In the multi-access network, whenever there is a update, that update firstly go to DR and BDR router. DR and BDR, designated router and backup designated router. Now, DR is responsible to update that information to rest of the router in the area. BDR will just keep the updated information. When DR goes down, then BDR will become DR. Clear this process?
Yes.
Okay. So now the next question, who will be the DR and who will be the BDR? So DR BDR election. So first thing, highest OSPF interface priority. The router which is having the highest OSPF interface priority will be the DR. Default priority is 1. Default priority is 1 on all the interfaces, all OSPF interfaces. Okay. So if you want to make any router, let's say R2 router as a DR, R2 is having more memory, more CPU utilization. So you can make R2, right? So you have to just increase the priority. So you can change the priority 1 to 50. Next, let's say priority tie in this case. Then second, highest loopback IP address. So right now in this scenario, there is no loopback. Third, highest physical IP address. So that's why 10.5 is my DR and 10.4 is my BDR due to the highest IP address. Clear now? If you want to change priority, so what you can do, you can go to the router interface. Let's say interface, whatever interface is there, fast Ethernet 0x1. You can define IP OSPF priority, let's say 50. And after that, that router will become the DR. Once you change the priority, you have to refresh the OSPF process. So just to refresh the OSPF process, there is a command clear IP OSPF star. Clear IP OSPF process star. OSPF states. So in OSPF, we have 7 state: down, init, two-way, xstart, exchange, loading, and full. So these are the 7 states. Down means I configure the OSPF I'm sending the hello packet, but I haven't received any hello packet from the neighbor. So you can say hello sent, waiting for hello. Once hello is received, so state change down to init. In two-way, hello compare, and neighborship form. So once neighborship is formed, if the topology is multi-access network, then it will start election of DR and BDR. In exchange state, DBD packet exchange. DBD packet exchange means my neighborship is formed. Now both the routers are exchanging the DBD packet, the routing updates. Load information from DBD to routing table. Once the information is updated in routing table, then state will be full. So routing table will synchronize completely. So these are the 7 states. So let's see if anything is pending in OSPF. So OSPF is a link state protocol. We already discussed link state protocol are more scalable. Each router have full picture of the topology. Update are sent through a topology change occurs and reflooded periodically. Link state protocol respond quickly to the topology change. More information is communicated between the routers. So whenever they are sending update, they will send update in the form of LSA. So firstly, they will form the neighbor table. After that, they will make the topology table and then routing table. So in the routing table, you will get only the best route information. So it's a link and state protocol. All these things we already discussed. Now, if it is connecting to the external domain, means to connect with another routing protocol. So backbone area, area 0, area 1, area 2, these are the standard or regular areas. Okay. Establish OSPF neighbor adjacencies. Adjacency is your neighborship. So to form the neighborship, these conditions must be matched. Router ID must be unique. On every router, there must be a unique router ID. So by default, it will take the highest IP address present on the router as a router ID. Next, hello and dead interval must match. Area ID must match. Authentication type and data must match. And stub area flag must be matched. So whatever is the star options, those must be matched to form the neighborship. So these are the states whatever we are discussing till now. It sent hello, received hello in its state, neighborship form in the two-way state. Then they will start the extart state. They will elect like who is the DR, who is the BDR. Once the election is done, then they will exchange LSDB. LSDB is the link state database, which is the DBD packet. So they are exchanging the DBD packet. They send the LS acknowledgement. And after that, the state will be full. These 5 type of packet we already discussed. Okay. So they configure OSPF in this topology. We'll do this lab. Okay. How to configure this thing? OSPF configuration. So let's say we have these two routers, R1 and R2. So same way, router, OSPF, any number. This is your process ID. Process ID is locally significant on the router. It's not mandatory you are putting same router ID, same process ID on every router. Not mandatory, but it's recommended. After that, you have to define network. Network and directly connected network. For example, if you are on R1, then this is the directly connected network. It's /8. So what will be the wildcard mask? The wildcard mask will be 255.0.255.255.255. This is the wildcard mask. Then you have to define area and area ID. So let's assume all the routers are into the area 0. So this is the area ID. So same way, network, 10 network, area 0, and exit. So how this value come? Subnet mask is 255.0.0.0. If you want to calculate the wildcard mask, you have to subtract your subnet mask from the full octet. So 0.255.255.255. So this is your wildcard mask. Clear this configuration?
Yes.
So now we are doing the lab. In the same network, I am removing EIGRP. Now we have to configure here OSPF. So router OSPF, any process ID, then network, for OSPF, I'm going to configure multi-area. Okay. So for the multi-area network, so this is my area 0. And this will be area 1. So 12 network will be in area, hold on. Then wildcard mask, area and area ID. Area is 0. After that we have network 10, which is in area 0. Then on R1 we have a network 13, and network 13 is under area 1. So this will be the configuration on R1. Same way on R2, router OSPF 1, network 12, then wildcard mask, then area. 12 network is under area 0. Then on R2 we have network 23. So you can see the neighborship is formed. It formed the neighborship with the help of with R1 router. 23. And 23 is in area 1. Then we have a network 20. On R3, all the subnets are under area 1. So router OSPF 1 network 23. Sorry. It should be under area 1. Then we have a network 30 and we have a network 13. So this will be the configuration on all the routers regarding OSPF. So let's see the routing table now. So OSPF verification, first thing you have to run show IP OSPF neighbor. So you can see you had 2 neighbors. Next command, show IP OSPF database. So in the database, you are getting this router, network LSA, summary LSA. These are the basically LSAs. In OSPF, we have total 11 type of LSA. Okay, these are the advanced concept which we are discussing into the CCNP routing and switching. But let me tell you, router LSA is the LSA 1. Every router is generating LSA 1 information. So that LSA 1 is having the information how many networks are directly connected with me. Then network LSA, it's a LSA number 2. LSA number 2 is generated by the DR router. LSA 3, summary LSA. ABR router will generate LSA 3. So in LSA 3, there will be the information, okay, all the intra routes, the route which is traveling from one area to another area. Okay. Show IP OSPF database. Show IP OSPF interfaces. So you will get all the interface information on which you enable the OSPF. If you run show IP OSPF neighbor, so you will get your state is full and this router is right now BDR, backup designated router. Why the BDR is there? Because all the routers are connected through the fast Ethernet cable. So if you are connecting routers through the fast Ethernet cable or through the switch, that type of topology is known as multi-access network. Show IP protocol. So you can see OSPF 1 is running. Here maximum path is 4. These networks you advertise and the AD value is 110. Router ID by default, router will take the highest IP address present on the router will be the router ID. And you can see your router ID, show IP OSPF database. So this is the router ID. If you want to change, you can change it. So how to change? You have to go to the router OSPF 1 and the command is router ID and whatever IP address you want to give there. So let's say I want to make it 10.0.0.1 as a router ID. So once you enter this command, you are getting the information reload or use the clear IP OSPF process command. Reload is not recommended into the production environment because if you have to just refresh the OSPF routing, but if you reload the device, then the complete device will be rebooted and whatever service is running on that particular device, at that time all services will be stopped. So after that, you have to run the clear IP OSPF process. And yes. So once you clear the process, your neighborship will break and again it will start the neighborship. So you can see now your router ID is changed now. Show IP protocol, show IP OSPF interfaces, all these commands we done. Show IP route. Okay. Show IP route. See this output carefully. There is a network 30 which is coming via O, and there is a network 23 which is coming as a OIA. So O means intra route, the route which is coming from the same area. OIA means inter area routes, the route which is coming from another area. So OSPF metric, if you want to manipulate the OSPF metric, you can manipulate. So the command is IP OSPF cost 1. Passive interface, same thing. If you want to block sending update to the particular interface, so you have to enter into the router OSPF. You can define passive interface and then interface, let's say fast Ethernet 0x0. If you define this command passive interface default, then it will put all interfaces into the passive mode. And after that, you can put no, let's say if you want to allow a particular one, firstly, you are running this command passive interface default. All the interface will become the passive now. Now, after that, you want a particular interface should not be a passive. So you can use no keyword and you can remove that particular command on that interface. OSPF in multi-area network. So let's say area 0, area 1, area 2. So they're describing the same thing. ABR is that router which is connecting to OSPF area. ASBR is that router which is connecting OSPF and with external AS or with external protocol. single area configuration, multi-area configuration. So same type of configuration we done right now. Okay. With IPv6, we'll do on the last day. Same OSPF on IPv6 because we have to learn IPv6 from the beginning, right? So firstly we'll do IPv6, then we'll see how we have to implement IPv6 on RIP, EIGRP and OSPF. So this IPv6 topic we'll do at the end of the course. So there is a discovery lab 43 and 44 regarding the OSPF. So 43 is OSPF with single area configuration. Then 44 is OSPF with multi-area configuration. We have to do these two discovery. Clear now? So anyone feeling hungry? Okay, let's take a lunch break and then we'll meet after 40 minutes and we'll do these two labs, and after that we have to do ACL, access control list.
Thank you very much. See you guys. Talk to or hear you later.
See you later.
Thank you, sir.
Bye.
Bye.
Access control list. This topic is very important. Based on the access list, you will get a simulation in your exam. Now, ACL, access control list. An ACL is a Cisco iOS tool for the traffic identification. ACL is a list of permit and deny statements, and ACL identify the traffic based on the information within the IP packet. After the traffic is identified, the different action can be taken, and ACL can be used on the router and switches. So basically, access control list is used to filter network and to filter the packet. Access control list used to filter network and packet. Also used to select or permit network. Now ACL is basically configured based on the number, which is known as number ACL, and can be configured with the name known as named ACL. Under the name and number, you have standard ACL and extended ACL. No. So firstly, I'm discussing number ACL. In the number ACL, firstly, we are going to discuss standard ACL. Now, standard ACL design according to source network. You cannot filter particular protocol traffic. In standard ACL, either everything is permit or everything is denied. So you cannot block, let's say, if you want to block particular telnet traffic, particular SSH traffic or FTP traffic. So particular protocol based filtering we cannot do with the help of standard ACL. Range 1 to 99. It's a normal range. Normal range of standard ACL. 1300 to 1999. This is extended range of standard ACL. Okay. So let's say we have an example. Let's say we have this example. If I'm telling network 30 should not communicate with network 10. So in that case, which network will be the source? Anyone? Network 30 should not communicate with network 10. Which network will be source network? Network 30 should not communicate with network 10. So in that case, this 30 is my source and 10 will be my destination. So standard ACL always design according to the source network. Next is extended ACL. Is designed with the help of source and destination network both. You can do particular protocol based filtering. So if you want to block a particular protocol, particular traffic, then you have to implement extended ACL. Range 100 to 199. It's a normal range. It's a extended range. So when you define access list and access list number, so based on the number, router will automatically identify it's a standard ACL or it's a extended ACL. Next. Rules for ACL. First rule. ACL always implement near to destination. Second rule, wildcard masking use. Third rule, if you enter any deny statement, you have to give permit statement also. Otherwise, whole network will be down. This is called as implicit deny. Router read statement sequentially and take action according to sequence. So these are 4 golden rules for ACL. Now, ACL configuration. ACL configuration can be done in 2 steps. First, create a ACL, then apply ACL into interface. Okay. When you are applying ACL into the interface, then you have to define the direction also. So for example, it's my R1. Here is network 10. Let's say on 0 by 1. And this is 0 by 2. And here is network 10. So there is a network 30. I want to block 30 to communicate with network 10. So in that case, this network 30 is coming via R2, via R1 it will reach. So when it reach to R1 on this interface 0 by 1, so in that case the traffic is in, and when it's going to network 10, in that case the traffic is out. So you have to take care this in and out. So when you are applying to the ACL, so direction is very important. So these are the types of ACL. Okay. So you can see they are creating access list, access list number, permit, and the particular network. So they are permitting this particular network. They are calling this network into the ACL number 1. So when you give ACL 1, that means you are creating standard ACL. Now if you write show access list, it will give you the information of your statement. And by default, whenever you give a statement, router will automatically provide a sequence number 10. And the next statement will get sequence number in the increment of 10. So like 10, 20, 30, 40. Okay, so through this example, they are going to explain only these users belongs to this subnet, they are able to access telnet. So what they are doing, they are creating a access list. In that access list, they are matching a particular network, and they are calling that access list into the line VTY. So only from that network range IP addresses, they are able to access this R1 router. So telnet, and you are able to telnet this thing after that. Same way, they are creating the access list, and they are selecting this particular network, and they are calling to 20. So now these two subnets are able to access telnet. So all these are configuration tasks. Okay. So let me show you one example. So we have this network. Let's say I'm the PC number 5. I want to check communication with 10.0.0.2. I am unable to communicate. Why? Show IP protocol. OSPF is running. Show IP route. I'm not getting network 10. Well, let me make a simple topology. Okay. So I configure EIGRP. So let's try to communicate. I'm able to communicate. So first thing, we are going to do standard ACL. In standard ACL, standard ACL. So task is network 30 Should not communicate with network 10. So firstly, you have to identify who is your source and who is your destination. So here, this is my source. This is my destination right now, according to this statement. So what you have to do, firstly, you have to create a access list. Now I am able to communicate. Now, network 10, my destination is on R1. So you have to create ACL near to the destination, and near to the destination means on R1. Then access list. After access list, you have to give the number. Any number you can give between 1 to 99. So let's say I'm giving here 5. This 5 is the ACL number. Then deny. To whom you want to deny? Network 30. And the wildcard mask of network 30. There is another rule. If you give a deny statement, you have to give a permit statement also. So access list, same access list number, permit, any. Any means rest of all. So if you run here, do show access list. So you can see you give two statements. One is the deny statement and one is the permit statement. And this 10 and 20, these are the sequence number which automatically generated by the router and in the increment of 10. Now, so ACL is created. Now you have to apply this ACL. So you have to apply this ACL where? On this interface or on this interface. So if you see your network, when the network 30 traffic is coming like this way, on 0 by 1, the traffic is in, and when it is going to network 10, the interface is 0 by 0. So you have to apply this on interface 0 by 0. IP, access group, access list number, same access list number, and out. Out means outbound direction, because the traffic is going out on this 0 by 0. Enter. So you create this access list on R1. So now let's see, your traffic is moving. So you can see the traffic is drop on R1. You are getting reply from till 12.1, means your traffic is reaching to the R1, but due to the access list, this router is blocking that traffic to go inside into your network 10. If I remove this last command through the interface, you can see again the traffic started. So when the traffic is coming to any device, firstly it will check the ACL. So whatever ACL is there, then it will check what is the condition into the ACL. So based on the ACL, it will perform the action. So this is the standard ACL example. Any confusion in standard ACL?
If I can add one thing, if you deleted the access list instead of removing it from the interface, you would get an explicit deny and it would block everything. Because I've done that by mistake before.
This thing? See, firstly, I just create the access list. If you are not applying the access list, there is no use of that ACL. So those are the normal ACL. Your traffic will be not blocked until you are not applying that ACL on any interface or in any VLAN or in let's say line VTY04. So after creating the ACL, you have to apply that ACL. Then only it will work. So on this PC, I'm assigning a IP address. I added a new PC. Let's say the IP address is 1.100. And in this PC, I'm enabling HTTP service. Service is on. Okay. No access list 5. So I'm removing that access list. So right now on this router, there is no access list. I can ping. There is a PC which is having this IP address. Oh, sorry. I am able to access that server, that PC through HTTP. Okay. So right now HTTP protocol is working. So if you want to block particular HTTP traffic, that is not possible through the standard ACL. In standard ACL, either everything is permit or everything is deny. So if you want to block a particular protocol, then you require extended ACL. So now next task is extended ACL. In extended ACL, we are blocking HTTP protocol. Okay. So for the extended ACL, you had to use number from 100 to 199. So let's say here I'm taking 115. Access list number, then deny TCP. Why TCP? Because HTTP protocol belongs to TCP protocol suite. Then to whom you want to block? I want to block network 30 traffic. You can block a particular host also. I will show you after that. Network 30, then wildcard mask of the 30. This is the source information. Then destination. Now destination is my particular web server. So for the particular PC, you have to use host keyword and the IP of that particular host. Then EQ. EQ means equal to. This is the port number, defining the port number 80. Why? Because HTTP protocol work on port number 80. So there are 3 parameters. Either you can give equal to EQ equal to the exact same port number, or you can give LT less than. So if I give LT 80, so less than 80 port number, all protocol are blocked. There is a GT greater than. So based on the parameter, you can block the port numbers. So here in this statement, I am telling if any traffic is coming from 30 network for that particular user, particular IP 10.0.0.100 that should be dropped. It's a deny statement. You have to give permit statement also. Access list number, permit, IP, any source, any destination. Again, I just created the access list. Now you have to apply this access list. IP access group 115 out. So this is the example of extended ACL. You can see I can ping 10.0.0.100. But I am unable to access HTTP because HTTP protocol is block. It is not giving me the web page option. Let's try with HTTPS. Through HTTPS, it is opening. Why? Because we blocked the port number 80 and HTTPS work on port number 443. Clear this thing? Any question?
No questions.
Go.
Okay. So now let me tell you one thing. This question will come in your exam. Exactly same question will come in your exam. Okay. So you will get this scenario in the exam. The question, question is not written here, but let me tell you the question. So question is like this. There is a corp router. This router is connecting to the service provider and this router is connecting to data center. In that data center, there are 3 servers: finance web server, DNS server, and public web server. So the first question is like this. There is a user C, this CPC. This user should able to access this finance web server through web browser. If I'm talking about through web browser, that means I'm talking about the port number 80. Clear this thing? So here first condition is this PCC should able to access this finance web server through port number 80. Next statement, all the rest of the user should not able to access this finance web server through port number 80. Second condition clear? Third condition is all these users, A, B, C, D, all these users should able to access the rest of the servers, means DNS server and public web server. So in the question, there will be 3 statements and there is a condition. You have to use maximum 3 commands. So maximum 3 command. First command is to allow C, PC number C. Second, deny every user to access the finance web server Third, you have to give the permission to all the users to access the rest of the servers. So this is the question. What will be the solution of this? See, whatever is into the pink color, this is the solution. So this is the condition number 1. Access list number, permit, TCP, and host. This host information is for the particular C user. This host is able to access this finance web server with the port number 80. This statement is clear. Access list number, permit, TCP. This is the information of the source, information of the destination, EQ port number 80. Next statement, access list number, deny, TCP, any. Any means all. To access this finance web server with port number 80. But due to the first statement, PC number C is able to access. Then last is access list, permit, IP, any. So that rest of the servers are able to accessible. And you have to apply this ACL into the downward direction. This interface is 0 by 1. This interface is 0 by 0. Clear this thing? So from that scenario, there are 5 questions. From that 5 question, 1 question will come the exam. So this is the question number 1. If you go down in this, there will be these modifications. Modification number 1, modification number 2, modification number 3, and modification number 4. Any modification can come in the exam. Either that first question will come or this modification will come. So in this modification, this is the question and this is the solution. So like C, in this question, they are telling, okay, C should be able to access. In next question, they can ask like, okay, B should be able to access like this. If you see the modification number 1, it is telling you have to give permission to B to access the finance server. Okay, so you have to practice this thing. So today you have to practice on this. Tomorrow you have to ask if you have any question, because this simulation is very important to pass the exam. Rest of the simulations are easy. This is little bit tricky. So I share this link on your chat. So you can read. If you have any question, you can ask. And if you click on this link, HTTP, this one packet tracer file will be downloaded. So you can practice in that. Okay. For example, if you download this, it will be downloaded. Like this file you will open. If you just install the Cisco packet tracer and double click on that, that file will automatically open and you will get the same scenario. After that, you have to just follow the steps and you can practice. Clear this thing? Any doubt in this?
I understand the access list commands, but I have a question.
Yes.
Maybe I missed something yesterday, but where can we get Packet Tracer? Because I've just been using the.
Okay, I haven't you can download the Packet Tracer from the internet. Okay. If you want, I can share the Packet Tracer through WeTransfer today. Okay. After this session, I will share everything on the mail
Thank
ID. So today you had to try this access list. Okay, one more thing. Okay. So in the exam, this RIP version 2 also come. It's a troubleshooting. Troubleshooting in the sense they will give the scenario like this. You can see the configuration. Once you click on the device, you are able to see the configuration. You can run show run command and you can see all the configuration. The questions will be there. Multiple choice question will be there. And you have to identify the correct answer based on the multiple choice questions. So like in this question, they are telling server 1 and server 2 are unable to communicate. These two servers are unable to communicate. They are in different VLANs and into the different IP subnets. Your initial check, the system administrator will show the IP address setting are correctly configured on the server side. Means on the server, there is no problem. IP address is configured fine. What could be the issue? So here they are telling like, okay, VLAN encapsulation is misconfigured on the router subinterfaces. Okay, this question we haven't done till now. Why? Because this question is related to inter-VLAN routing. It's a switching concept, inter-VLAN routing. We have to do that task. So here R2 is doing inter-VLAN routing, means communication from VLAN 10 to VLAN 20. So there is a problem into the sub interface. So that's why the answer is A. So you have to read these questions also on this simulation. From that, 4 questions will come in your exam. Okay, who is going to give the exam after this training? Everyone, or you are just waiting for a few days and after that you are giving the exam?
Yeah, I'm gonna probably do it as soon as possible, actually.
Okay. So try to give exam as soon as possible. So whatever questions I'm telling, those are the current questions which are coming into the exam right now. Okay. So this will also come in your exam. But I'm not explaining this thing right now because we haven't done IPv6. So once we'll do IPv6, then I will explain this thing. Okay. So in this, there is a discovery lab of ACL. Discovery number 11. Try to complete this discovery. 11. If it is complete, then let me know. Then we'll move to the next topic. Okay. So whatever ACL we have done till now, that is the number ACL. So in the named ACL, configuration will be same. Just you have to configure the ACL with the name. So for example, if you want to configure a standard ACL with the name, so command will be IP access list. Then you have to give standard or extended, then the name. So here they are using the name subnet underscore only. This is the name of the standard ACL. Any name you can take. Inside that, you can define your permit and deny statement. So that will be your access list creation. Then you have to enter into the interface, particular interface where you want to apply, and then you can define IP access group, the name of access list, and in or out. This is the named access list configuration. Now, what is the advantage in named ACL? So advantage is like this. If you create number ACL and if you want to modify something, for example, you are creating number ACL, let's say. So when you are creating number ACL on the routers, so first statement you are giving, let's say deny 30. Second statement you give permit any. And after that, if you give deny 20, so this 20 will not work. Why? Router gives sequence number 10 to this statement, 20 and 30. So when the traffic comes to the router read statement sequentially. So it will check, okay, sequence number 10 is telling you have to deny 30. Then network in second statement, everything is permitted. So all networks are permitted, including this 20 also. So after that, if you are giving deny statement, that deny statement will not work. If you want to deny this 20, so what you have to do? Firstly, you have to remove this, then apply this here and this in the last. So this is the problem into the number ACL. If you want to modify something, you have to remove first and then reconfigure that thing. Whereas in the named ACL, we can define manual sequence number. Manually, we can define the sequence number. So if we want to define this thing, I can define sequence number, let's say 15. So automatically it will come here. No need to remove any statement. So in named ACL, you can manually define the sequence number. This is the advantage. Rest of the working implementation, everything is same. Next. NAT. Network address translation. So NAT is used to translate public IP to private IP and private IP to public IP basically. So NAT allow private user to access internet by sharing one or more public IP addresses. Types of NAT. So NAT is used to translate private IP to public IP and vice versa. No. Okay. Inside my network, I always use private network. And to connect with the ISP, I always connect with the public IP address. So NAT is used to translate public to private and private to public IP address. Why? Because on the public IP address, we can directly access internet. So when in the netting, when the traffic reach to the router will change the source and it will put the public IP into the source and it will forward to the external world. So in that case, this R1 is behaving as a NAT device. So when this router is behaving as a NAT device, you have to define, okay, which interface is connecting to your internal network and which interface is connecting to the external network. So for example, 0 by 1 and 0 by 0. So you have to define this 0 by 1 as a outside network and this is inside. Types of NAT. So on the router, we have static NAT, we have dynamic NAT and PAT, port address translation. Now, first thing, static NAT. In static NAT, we bind particular private IP with a particular public IP, so that that particular private user will able to access internet. This is known as one-to-one map. Next one is dynamic NAT. In dynamic NAT, we bind a pool of private IP with a pool of public IPs. This is known as many-to-many. Last one, PAT. Port address translation. Also known as overloading NAT. In PAT, we bind whole private network with a port which is having public IP. This is known as all-to-one map. No. So for lab, let's say this is my ISP. This is my internal router. Now, in my inside network, let's say my network is 192.168.1.0/24. And here on the public side, so this is my private network. This is my public. So these users want to access internet. So netting is basically used to access the internet. So in this lab, what I'm going to implement, I will implement net on the R1. So firstly, I will define this R1 is a net device. So to define this NAT device, you have to define this is your outside interface and this is your inside interface. And after that, you have to implement static, default, and dynamic NAT. So static, dynamic, pat, many to one. So you have to define what is your inside, what is your outside. So this router will create a NAT table. In that NAT table, it will make all the entries. This private IP address resolve into which public IP address. So everything will be there into the netting table. So to configure the static NAT, this is the command to configure static NAT. IP space NAT space inside space source, the particular private IP address with the particular public IP address. So let me show you this lab. So this router is my ISP. And this is my local router. So here I'm using 200 network. And here I will use 192 network. This is my public network. Here is my okay. So firstly, I'm going to configure ISP. So on ISP, I'm not doing anything. I'm just assigning IP address. Okay. So till now I just assign IP addressing. There is no routing, there is no netting. So let's say, can I communicate with the ISP or not? On ISP we have IP address 200.200.200.5. We will not able to communicate because there is no routing, there is no netting. Okay. So to implement NAT, first task is you have to define netting on the R1. So to define the NAT on R1 means this R1 router will behave as a NAT device. You have to define interface 0/1 IP NAT outside. This interface is connecting to the outside network 0/0 IP NAT inside. So these two commands will tell to R1 you have to perform as a NAT device. So you have to define this thing on R1. So once you define, then you have to perform NAT. So in the NAT, first type of NAT is static NAT. So in static NAT, I'm giving access to PC0, which is having 192.168.1.2 IP address. So in the static NAT, IP space NAT inside source static and then private IP address 1.2 and bind with the public IP address, your own public IP address. So once you enter this command, this is .2. So now if you try to ping to the service provider, you are able to communicate. Now if you are able to communicate with the service provider, then service provider is responsible to provide all the internet services to you. So your first task is you have to communicate with the service provider. If you are able to communicate with the service provider, then you will get internet service. So this is a static NAT configuration. If you want to verify, you can run command show IP NAT translations. So this thing is known as netting table. If you want to clear this netting table, clear IP NAT translation star. So this table will be deleted. So here I'm removing the static NAT right now. Okay. Now next is dynamic NAT. In dynamic NAT is we bind a pool of private IP address with a pool of public IP addresses. So for example, from your network, you want to give permission to 2 users to access the internet. But those 2 users you are not defining. You are telling any two user from your network. So in that case, you have to create a access list. Access list number, permit, and give permit to your internal network with a wildcard mask. So through this command, I am selecting our network. After that, you have to define how many public IP addresses you have. So for that, IP space NAT pool, name of the pool, then let's say I have these two public IP addresses, 200.1 and 200.2. Then net mask is the subnet mask. Now, so first command you define your network, second command you define how many public IP addresses you have. Now you have to combine your access list to pool. IP space NAT inside source list, access list number, pool, and the name of the pool. So this is your dynamic net. So these are command for dynamic net. So let's try now. So now we have two public IP address. So two users will able to communicate with the service provider. One ping 200.200.200.5. Okay, so two users are communicating to the service provider now. Show IP net translations. So this is your netting table. So now I'm removing dynamic NAT. Okay. Now, PAT, port address translation. For the PAT, you need access list, then IP space NAT inside source, list, list number, interface, and the interface which is connecting towards service provider. And overload.
The access list number is 15, not 10.
Oh, sorry. My mistake. So now what we are doing, the whole network we are binding with this particular port which is having the public IP address. So now if you try, all users will able to communicate with the service provider. If you run here, show IP NAT translation. So it will create the complete netting table. So this is the NAT. So this is telling like this is your inside global, inside local. The traffic is coming from this private IP address, which is converted into this public IP address, and it is going out through this public IP address. So this is the service provider information, and this is your local information, inside local and inside global. Any question into the NAT? Okay. So for the NAT, there is discovery 13 and 14. So try to implement this thing, 13 and 14. whenever you are sending any data, before that data ARP request will go. ARP is address resolution protocol, which is used to resolve MAC address to the IP address. So whenever you are communicating with any PC or any system, so firstly ARP request will travel. For example, so I assign 10.1, 10.2, 10.3. So in this packet tracer, there is a simulation mode also. So let me show you what is the use of this. So let's say I am on PC 0 and I'm trying to communicate with 10.0.0. Let's say 2. So you can see you initiate the ICMP request, ping request. Before that ping, ARP request is started. So firstly ARP request will go to resolve the layer 2 information. So ARP is a kind of broadcast, so it will go to everywhere. So it is coming with the reply, ARP reply, and it is giving that information to PC0. So once this PC0 received the ARP reply, then it will send the ICMP request. Clear this process? So every time whenever you don't have any information of the destination MAC, then first ARP request will go and it will resolve the ARP request with the ARP reply. So once you receive the ARP reply, then it will forward the actual packet. So let's say if I open this first packet, so you can see in this layer 2 header information, this 000E, this is the PC0 MAC address. And right now this PC doesn't know the destination MAC address, so it will put FFFF as a broadcast. So it went to the source IP and destination. So it received by the switch. So switch is doing the same thing. So when the switch receive any packet from FFFF, it will forward that packet to all the active ports. So now this request is resolved by the PC number 2 and you are getting here the destination MAC address now. So once you receive the destination MAC address, then the actual packet will start. So the same thing they are explaining here. So firstly, the packet will be broadcast because this PC doesn't know where is that destination MAC address. So once it received by the destination, so ARP reply is always a unicast. So it is sending a unicast and it is received by the source. Same thing. Now, this is within the LAN, local area network. But let's say if there is a router between, then what will happen? So in that case, if the router is there, then ARP request will be received by the router. Router put its own MAC address into the destination MAC and it will forward to the source. By default, router allow only unicast packet. If any broadcast request is coming to the router, any multicast request is coming to the router, that will be dropped by default. If you want to allow multicast, you have to specifically allow multicast. You have to enable the PIM protocol, which is used in multicasting, PIM and IGMP. So by default, if any broadcast traffic received by the router, it will put its own MAC address information into the ARP reply and it will forward that information to the source. ARP-A, this is the command to check ARP entries into the system. On the router, you can run show IP ARP. Default gateway. If you are communicating within your own IP subnet, in that case, there is no requirement of the default gateway. But if you are going outside your subnet, then you need a default gateway information. If you want to define a default gateway on the PC, okay, here this PC is basically a router. They are just changing a name to the PC1. So if you want to define a default gateway on the router, the command is IP default gateway and the IP address of the default gateway. Ping, show ARP, all these things. If you want to clear any ARP entry from the ARP cache, you can run this command. Clear IP ARP and the particular IP address entry. So it will clear that ARP entry with the help of this IP. So they are going to explain the same thing. This is a host A, host B. They want to communicate with each other. So routing is there. So firstly on the application layer. So network, I have some data to send to this network and I do not need a reliable connection. On transport layer, it will use the UDP protocol. Okay, there are two protocols, protocol shoot. One is the TCP and one is the UDP. TCP is connection oriented protocol, UDP is connection less protocol. TCP work on port number 6, UDP work on port number 17. TCP is slower and UDP is faster because it forwards small amount of data. So here it will forward with the help of UDP. Application layer, like, okay, this data you have to forward. So here layer 3 information, this is the source information. It will forward to the default gateway. Now default gateway, it will check the routing and based on the routing, it will forward that request to the host B. So these are the information of PC. Default gateway means on this interface like 192.168.3.2, and this is the MAC address of particular this port. On this this interface, the IP address is 192.168.4.1, and this is the MAC address information. This information is of host B. So it is putting like header information, whatever I shown you into the packet tracer. So ARP entry, then UDP header will be there. It will contain the source IP, destination IP, UDP header, and ARP data. So it will forward that request to the next device. It will receive here destination broadcast, source MAC, ARP request. Based on that routing, it will forward the request to the host. Ping and traceset command we already discussed. Show MAC address table. This is the command on the switch used to see the MAC address table. If you want to clear the MAC address information, you can use this command. We will do all these commands tomorrow when we are doing the switching. Okay. So static routing, all these things we done. Okay. So today you have to do all these discovery, whatever we done today. So I'm explaining from the beginning, discovery 1, discovery 2. What is this? In discovery 1, there is a basic commands, like all the show commands, whatever we discussed yesterday, like show interfaces, show IP interface brief, show history, show running configuration, show startup configuration, all those commands. Perform the basic switch configuration, like in this, all the show verification command of the switch. So tomorrow we'll do this lab, discovery number 2, because today we just complete the routing task. Discovery 3 will do tomorrow. Discovery 4 will do tomorrow. Discovery 6, router configuration will done this lab. Discovery 7, CDP and LLDP protocol, we done this discovery lab. Discovery 8, 9, you have to do right now. After that, discovery 10 and 11 we done. Discovery 13 and 14 we done. Troubleshooting you can do, that is netting troubleshooting. Discovery 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Till 25 we'll do tomorrow, because all these labs are switching labs. Discovery 26 we done. 27 is related to the RIP. You can do that thing. IPv6 we haven't done till now. (31) labs we done, like extended list. You can try this thing. EIGRP lab we done. IPv6 lab is pending. OSPF single area and multiple area is done. OSPF version 3 is pending. OSPF version 3 is OSPF with IPv6. Okay. So this is the agenda of the day. Any question you want to ask, like whatever topic we have done today, you can ask.
I'm sure I have a lot of questions as soon as I figure out everything that I learned today. So I appreciate your time. But right now I don't have any.
Okay. So try to do all these discovery. If you have any question, you can ask. Okay.
Okay.
Thank you again, Rakesh, for all of your tutoring today, and looking forward to working with you again tomorrow.
Sure, not an issue.
Thank you. All right. Good night, everyone.
Good night.
Good night, everyone.
Bye, guys.
Bye.
Bye.